of cellulose that can be used instead of the natural wood fibers, and they are looking into how this would impact essentially the quality. Making a mapping of the challenges dealing with is ongoing, and I hope we will get new results and interesting tracks out of that. With that, I would like to thank you for your attention.
Okay, we thank Romain for sending us this presentation in the consolidation of encaustic painting, which is very, very important, as well as for packaging material, material that concerns a lot conservators. Now we can pass to the next presentation by Kostas Galiotis, who will speak about graphene-enabling solutions for preventing conservation of cultural heritage. Kostas is the founder of the only graphene center in Greece, in Forth, and he is head of the national representation in the Nanomaterials by Production Committee of Horizon 22 and previously in FP4 of the Commission of European Communities. He has a lot of activities in Europe and all over the world, served as expert reviewer, independent observer, and vice chair for evaluation of European research, many European research proposals. And among others, his master's, his evaluator in the master courses and PhD degrees in the UK and in Greece. I'm sorry for this brief presentation, Kostas, but I could not read the extending CV I found. Okay, thanks again for participating in this conference, and we hear you. Please open the microphone. You have the microphone muted, Costa. It's still muted. We can get it muted.
Okay.
Okay, perfect.
Yes, let me go back to the presentation. Do you see the presentation?
Yes, it's a presentation mode. It's not okay.
Yeah, but I don't see it myself now. I had to go back to the, just 1 second. Okay.
Okay, we can proceed like this. It's not full screen. Okay, now that's perfect, perfect.
Okay, so as you've heard, thanks very much, Athena, and thanks you and Christiana for organizing this. The talk will be not just for green materials or green nanomaterials. I will talk about the role of graphene in preventive conservation in a broad sense. And you can see all the co-authors, which are people who have actually over the years worked hard to make this happen. And as you've heard, I'm an emeritus professor at the Department of Chemical Engineering, University of Patras, and involved with Forth for many years. And also we had, as you said, the first graphene center in Europe, I think. Anyway, when you turn on the news every day, then you always think of this painting on the left, which is scream. You know, you just listen to the news and you want to scream. Anyway, this is a beautiful painting by Edgar Munch, and that's how it was in the past. And I don't know if you see the cursor, my cursor, and this is how it is nowadays. What is happening here? Why you get this discoloration of the yellow into white is because always when you have natural light or UV light, then you get a photolysis of dyes, of these beautiful dyes. They give nice colors. Here we have as you could see, the breakdown of all these chemicals, which is the azo bonds are cleaved, and therefore you end up with this product at the end, which is of course clear and not yellow. Other things you have is gaseous pollutants. Think of the exhibition at Louvre in Paris. You have internal pollution from all the other art pieces of the museum, also from the visitors and what they carry. And they have a lot of VOX, which is a volatile organic compounds, like formic acid, acetic acid, formaldehyde, etc. And also you have external pollution that is brought into the exhibition from the environment. Then another thing that you have is a lot of pieces of art, a lot of paintings in storage rooms, and they are under really variable conditions of temperature and humidity, and that is quite bad for the piece of art. And then also they are exposed to fungi, which are mostly airborne infections within the environment, and you have to protect the piece of art from that. And in fact, 96% of all museum collections are held in storage in this quite really variable and I would say destabilizing conditions for the piece of art. The consequence of this is the discoloration of the paintings, as I mentioned, the loss of mechanical integrity, fracking, cracking. Maybe you've seen even Renaissance paintings be completely cracked. So what the International Council of Museums says, it says that we have to define conservation of tangible cultural heritage in two modes. One is the remedial conservation mode, which is actions directly apply onto an item to delay damaging processes. And this will do with graphene, as I will show you later, very briefly, of course, because of the time constraints, using graphene as a protective coating, or using graphene into inks to protect and to restrict the discoloration of these inks. The other thing is preventive conservation, where you work on the surroundings, as you will see here, and not directly, in fact, to the piece of art. Here, in that case, we have, and we'll show you, things we can use 2D materials as sensors for relative humidity, VOX, and temperature monitor, and also we can use absorbers made of 2D materials, in fact, against pollutants. So all this is based on the discovery of the first 2D material. Now there are thousands of 2D materials. We live in the age of 2D materials, I'm afraid, where you start with, let's say, a pack of cards. You start with one card, so it's one layer of graphite. It's called graphene, and because it's only one layer, it has no three-dimensional character. is absolutely perfect, has very high properties in all fields, electrical, mechanical, and thermal, etc. So Andrew Geim and Costa Novosel discovered this, isolated. I worked with these guys from the very beginning, and now I can show you a very brief layout of production of graphene. We can start from graphite. Graphite is an abundant material on Earth. It's not a critical raw material, so still is not really under threat. And what you do, you buy graphite, which is cheap, with liquid phase. You exfoliate it through liquid phase, and then you have nano additives, graphene flakes. And you can use a green synthesis. You can use green solvents to do that. On the other side of the spectrum, you can oxidize graphite and make it hydrophilic, and then you can reduce it back into something like graphene, a reduced GO, and we use all that for sensors, for pollutants, absorbers, etc. And where actually you apply a green synthesis for GO. And finally, we have the chemical vapor deposition, which is gives you the best quality single layer graphene and large area. I will show you that you can go into kilometers really on this. Now, people say, oh, that's not very green because it's a high temperature. Okay, yes, it happens at high temperature, but then you decompose a hydrocarbon, which is really something which you really want to decompose. You don't want to emit it in the environment because of global warming. Also, you can use any source of carbon to, in fact, gasify it and send it into the chamber. This can be any kind of rubbish that contain carbon, insects, tires, and all kinds of rejects from any factory or any laboratory. So source of carbon at high temperature is turned into graphene. And you have powder microns for graphene. You can have wafer scale CVD, particularly good for electronic applications. Or you can have a roll-to-roll CVD on copper, which is the best catalyst for graphene. It's a continuous process, as I said, mass production. And we have, as I said, in our lab, a 30-meter long times 20 centimeters, by centimeters wide monolayer graphene on a roll. So let's think of graphene as a protective layer. It's strength and flexible because it's so thin. It's transparent, only absorbs 2.3% of light. UV absorption, we discovered that it absorbs UV, which was quite surprisingly, and the more layers you have, the higher the absorption. And this is based on the fact that you have excitonic effects of pi to pi star transitions in this Brillouin spectrum of energy versus K space. And in fact, it can only happen in UV because of the energy required for this transition. You can also use a graphene as a gas barrier because it's so packed, the structure. Nothing can penetrate this structure, not even hydrogen. So it is an ideal barrier against other substances or even water. So it is hydrophobic. The roll-to-roll transfer, going back to that, is ideal for coatings. You start with a CVD foil, then you grow graphene, you take it into a roller. You really have to take the graphene out of copper through an adhesive film, and then you get rid of your copper. You have the graphene on the adhesive film, which can then be transferred to a painting that goes through the rollers. So this is one way of doing it. There are other ways of doing it, but as I said, here you can see, if you can, of course, that I can see it myself, but it's not really visible. That the half of it has graphene, monolayer graphene, so it's almost invisible, and the other half has no graphene. So, if we subject this to direct UV light, which is a very, I guess, a strong type of accelerating agent, with the help of our colleagues in CSGI in Florence, led by Professor Baglioni and his colleagues, who can do colorimetric measurements, you will see if that this is the area covered 1Z, the other is not covered by 1Z. The strip is covered with a membrane to avoid any kind of deterioration, and you will see that still the structure is still visible where the graphene was, and the structure is disappearing where there is no graphene. But this is, of course, direct at UV light is 90 years of exposure. So you expect this, but at least with graphene, you retain the structure of the painting. Of course, the colors is obviously degrade a little bit, and this was in fact expected. But what about white LED lamps that they have in museums? And this is maybe not really very well known, but they suffer from the same problem. So again, we have a painting here with graphene before and after, very little change, but without graphene, after 130 hours of artificial aging, which is about 65 years of museum exhibition, you will see a change of structure and, in fact, the slightly discoloration of this painting, particularly the strong colors. So graphene can, as a coating, can give you at least 30% improvement in the various colors. We have actually measured that for various colors. But of course, this is an accumulated effect, and over many years, this is a quite important bonus for coatings. Going to volatile organic compounds, this graphene really is behaving very well against exposure, let's say, to acetic acid. In this case, you have here a glossy type of paper painted green. This is after aging, you will see, and this is a glossy paper. And graphene really offers anything between 55 to 82% protection in this case. And if you are not convinced, you will see this is without graphene, and this with graphene, and you will see the glossy paper not being cracked, and 8 and 12 hours aging, it gives you quite considerable micro cracks present in these papers. And if you ask yourselves, well, can we remove graphene as a coating? It's very easy to remove it with a soft rubber. It's like when you remove pencil. I mean, when you write with a pencil, you actually write on a piece of paper. You deposit graphene, and this is what, because pencil is graphite, and with a soft rubber or a gel, one of like Piero's gels, we can very easily remove graphene, and you will see after removal the structure is still there of the painting. You have not impeded any damage onto the material. And the CBD is also, because it's on a roll, you can also transfer it to glasses or polymers, display screens or anything. And we are now working on transferring onto glasses using museums for UV protection. And the results, this is just, you will see the little shade here is a monolayer graphene, and this is a painting. The glass is over the painting, and we have results to show that they prefer extra resistance, extra protection to the painting with the gloves on. And recently, ourselves, in collaboration with CSGI, we got a US patent granted, and we're still waiting for the European patent, but Americans are a bit faster. So the actual patent is out, and it just refers to this, you can read it, it refers to this actually technology. Now, regarding artistic inks and paints, I think, okay, we're talking about different binders and pigments, additives, very nice colors, quite strong. And I would say that you have a whole sort of range of beautiful colors from different pigments. You can use in fact to paint and to use in paintings. Now the problem is these very strong colors fade very, very fast. As we're going back to my first slide with Munch. Okay, one way is to protect the painting with a coating. The other is to, in fact, enhance the pigments, the inks. And this is what we do here. And in fact, in this case, we use flakes, not CVD membranes. And you will see here example after, again, accelerate agent. You will see here that with under 30 years of, let's say, UV, the carmine is a reference, and this is covered here, non-irradiated area. The carmine with graphene flakes has not changed, has not altered. The colors have remained quite, in fact, unchanged. And this is quite impressive with ultramarine as well. So, and if anything, they become darker. Why? And this is what it's another patent that we filed, is a GO in this process becomes RGO. So the GO becomes something stronger and more resistant to deterioration. And this is the reduced GO, which is like graphene itself. So this is making smart paints. And it will be good for architectural paints as well as artistic paints. Finally, we have the aerogels that I mentioned, which we can use in exhibition rooms, storage facilities, etc., etc. So far, people are using activated carbon, silica gels, or polyurethanes. We believe that graphene-based porous materials in aerogels, which are lighter than air, have higher absorption capacity because they are quite completely porous and reusable, and it's antifungal, and it can be used straight into, let's say, as you will see here, storage type of chambers like the Gopion boxes, and other 2D materials can do the same job. We are trying to, aerogel production is not a very green process, but we made it green by not going to very low temperatures. We'll go to -18 with deep freeze, and then we thaw the material in an oven drying, using, of course, a GO structure with ascorbic acid in order to enhance the reduction into RGO in this process. And I mentioned waste tire, and from this is collaboration we have with the Sabancı University for Istanbul, that they have, they turn waste tire into carbon black, and then with further heating into graphene. And it's a good way, in fact, to use this type of waste material into graphene, and you can use for various applications. A benchmark study has shown that our aerogels, graphene aerogels, behave much better than all the other competitors, which are activated carbon, silica gel, polyurethane. They are absorbed like anything, the VOCs, like formic acid, acetic, ammonia, and formaldehyde. And finally, we can make with graphene, with collaboration now with Tyndall from Ireland, this National Institute, we can engrave with a laser into a polymer. We can turn the polymer into graphene-like material with a laser. We pyrolyze it and we make it graphene-like. And we can engrave a circuit, electric circuit. You can put gel on the top and make a chip sensor, quite green as well. And the sensor behaves quite well. It's capacitance over time. It has high sensitivity and fast response, and it's quite stable over repetitive measurements. And this is, it compares well financially as well as performance with existing commercial sensors. And Tyndall, part of the Green Project, the GREENART Project here, is also building a near-field communication device connected to our sensors, so you can go with your phone and check the temperature and humidity, relative humidity in a box and material which is stored. And this was also part, will continue from the previous European project we had. And this now is connected to real sensors that we're making this project. So this is all. I hope I kept the time. You can consult all these various publications, our patents that we have published, and on the left are our sponsors. And thanks very much for listening. Thank you.
Dear Kostas, thank you very much for this presentation. You managed in a very short time to introduce us to the world, to the magic world of graphene and the variety of solutions it can provide us in the protection of cultural heritage. It is very, very promising, all this, and we will be waiting the applications, the results of this research. And now Agathi wants to present me because it's the next presentation. I don't, don't say much because it's not necessary. Okay, just keep the protocol.
Hello, everybody. The next presentation is titled GREENART New Materials Evaluation Methodology, and the presenter is Dr. Athina Alexopoulou from the University of West Attica, Greece. Athina Georgia Alexopoulou is a professor at the Department of Conservation of Antiquities and Works of Art at the University of West Attica. She is a member of the University Board and manager of the university's partnership to European Horizon GREENART Project. She founded and currently leads the research laboratory Articon and has organized under its auspices scientific collaborations, research activities, and educational programs related to the protection and promotion of cultural heritage. She recently completed her appointment at the UNIVA's Council of Training and Lifelong Learning, as well as in the Scientific Advisor Committee in Culture, Tourism, and Creative Industries of the National Council for Research, Technology, and Innovation. A scientific activity covers the field of diagnostic non-destructive methods and chemical microanalysis of artworks and archaeological objects, for which she has received funding from multiple competitive national and European research grants. She has authored and co-authored monographs, scientific books, chapters in collective volumes, educational manuals, and many publications. Part of the educational material she teaches is freely available in open online academic courses.
Thank you, Agathi. Thank you very much for the presentation. And we'll try to share now. Ποιο είναι τώρα? Articon Lab, όχι. GREENART Meeting, αυτό. Το window. Okay, you can see it in full screen now. Well, we have attended the previous speaker's presentation, which focused on the new conservation materials, the cleaning gel and fluids, protective coating materials, consolidants, packaging materials, paper boxes, and new forms for storing or protection of the objects. We also saw how they can be produced from renewable sources or waste raw materials applying new green techniques. And of course, we saw the graphene solutions. In this presentation, we are going to investigate the proposed methodology for the evaluation of this new material. I will explain in brief the role and the aim of the contribution of Articon Lab in the project, present the particular methodology applied and the reasons to choose it, and discuss the selected artworks to experiment on them. As I have mentioned in my welcome speech, University of West Attica participates and contributes dynamically to the project through the Articon Laboratory in collaboration with the CLab and OPS laboratories. This is achieved by studying the effect of the new green materials on mock-ups or real art and heritage materials through different kinds of methods, in particular non-destructive examination, as well as non-invasive ones. In some cases, chemical and microchemical analysis is also applied. The study of the effect is carried out during preservation and artificial aging of specimens on a wide range of materials such as paintings, books, archival material, metal statuettes, etc. We also are involved in the evaluation of new green sensors. Finally, the sustainability of the green liquids under development is evaluated in the context of life cycle analysis. In engineering, there are, of course, many methods to investigate the interaction between materials, such as chemical analysis and microanalysis, mechanical testing, studying their topography and morphology, etc. However, as we operate in the field of art, we must follow the restrictions that originate from the artwork's nature and the socioeconomic role of the art on one hand. On the other hand, we should be functional and efficient in daily practice and at work in situ, at the place where the object is exhibited or stored. Our ultimate goal, after all the experimental work we are doing within GREENART, is to be able to provide professionals with useful low-cost tools, protocols, and guidelines to test by themselves in a first level, of course, and in a reliable way, the efficiency or the effect of the applied new material on the work. Today, imaging techniques are internationally at the cutting edge of non-destructive diagnostics of movable and immovable monuments and constitute a valuable research tool in the service of specialists and professionals in the field. Imaging techniques are attractive green technology solutions. They do not require sampling or dissect the structure. They can be applied in situ and give immediate results. They are user and environmentally friendly as they do not involve consumable or waste materials and have very low energy consumption. At the same time, with the development of information technology, imaging techniques are gaining momentum. They offer the advantage of being able to examine a wide range of objects, painting, frescoes, archival, book materials, ceramic, stone, etc., in a fast, reliable, inexpensive, and safe way, particularly in the case of high-danger objects or constructions, thus supporting a multidisciplinarity of works of art and providing significant added value. So, we are particularly interested in non-destructive methods of investigation that provide a recording of normal to macro-sized areas, such as visual testing and technical photography, as well as hyperspectral imaging with a step of minimum 2 nanometers. Additionally, we use methods as standard procedure that provide measurements of the optical properties of the surfaces, such as colorimetry, opacity, and glossiness. Analytical technique, such as portable XRF or portable FTIR, or in cases of mockups or sacrificing objects, where sampling is allowed, optical microscopy, semi-DEX and AT-FTIR are also in our choices. In cases where the mechanical strength has to be tested, we have chosen to apply tests on mechanical strength or tensile strength. The applied methodology for the evaluation of green materials embraces non-destructive testing and includes the following steps: selection of works, criteria set within each working group, preparation of mockups in case it is needed, characterization of the materials and structure of the works, characterization of the materials used for the preparation of the mockups, application of traditional materials and new materials and fluids, application of imaging techniques, analytical techniques before and after treatment, evaluation of the results in collaboration with the other partners. The sacrificing objects were chosen based on specific criteria. Sacrificing objects include works of art on paper, oil paintings, and panel paintings. All these objects represent basic categories of works that Greek conservators often have to deal with, but also have particular interest due to their structure, support, and the several superimposed layers, and the surface, chemical and physical characteristics. Bronze sculptures were chosen also as sacrificing objects, as they represent basic categories of alloys that Greek sculptors have used in the past, but also contemporary sculptures use currently. Thus, they have particular interest concerning their surface, chemical, and physical characteristics. All works were constructed within the 20th and 21st century in Greece. The group of sacrificing objects is completed by 19th century lead handmade paper that has lost physical strength and material was chosen as it presents particular interest for conservators due to its characteristics. Where needed, mockups will be used to test green materials before application in real cases. For example, where cleaner materials will be tested, this sacrificing object, a panel painting of Archangel Michael, was fully documented using symmetrical and raking light in the visible as well as ultraviolet-induced visible fluorescence. Surface gloss was measured on clearly specified locations, from these locations, FTR spectra were also obtained. Similarly, for the sacrificing object oil painting young men with red scarf, full, again, documentation was carried out using spectral imaging techniques. Measurements for gloss and the color was also obtained, and as well as IR spectra from the areas where the where the new materials will be tested. Referring to protected coating materials, 3 bronze statuettes were chosen. However, they act as guides in a sense that their characterization help us to prepare mock-ups and apply the coating materials on them before we proceed to real artifact. 2 of the sculptures were made by Yannis Papas, a very known Greek sculptor, and 1 by Praxtelis Giannoulinos, our colleague. We sincerely thank both the Yannis Papas Studios and the private collector for eagerly supporting our effort. After completing the optical properties and spectral images of these 3 items, which has been recording using the protocols as beforehand, we continue with semi-DX analysis from minute samples taken from hidden yet representative areas that allow us to look in the market for mock-ups of the specific composition in order to simulate the conditions. After appropriate processing, the mock-ups coated with conventional coating, the conventional material that conservators currently use, such as beeswax and incralac, and the new green protective ones, the mock-ups will be tested after natural and appropriate accelerated artificial aging. Assessment before and after aging includes documentation, semi-DS imaging and analysis, coating thickness measurement, gloss and colorimetric measurement, as well as cross-cut adhesion tests. As far as the new consolidants are concerned, we have chosen to work on archival material as the need of consolidation in this kind of material is very common. 18 pages from the same collection were selected for the treatment of consolidation. All the pages present similar damages and they were stored under the same environmental conditions. Papers have lost physical strength and present a physical degradation that makes areas of the papers very friable and brittle, which was obvious during handling. In addition, papers have a very fragile area at the edges with losses, several small tears and folds. In these areas, consolidants will be tested. I won't go into further details at this moment because the presentation's focus is different. In the case, apart from the standard imaging techniques and the optical properties measurements, we decided to perform mechanical strength tests on suitably prepared mock-ups before and after the treatment with consolidants. In the photo, we can see the morphology of the paper from 3 different areas. First figure, the morphology of a paper sample in good condition. Second figure shows sample in moderate condition, which presents limited deterioration, and third photo presents paper sample in bad condition. The dispersion of fungal spores is evident, and the paper fibers are completely disintegrated. Currently, we are preparing to apply conventional consolidants on fragile areas of the paper, and bibliography research is made regarding the nanocellulose film as consolidant. About 15 different packaging materials, paper, board from manual plants, and PPR hollow chamber sheets from different resources, such as conventional, recycled, and bio-based material supplied by Centrum for Buchenhaltung, ZFB, are under evaluation in our lab. In this case, we assess grammage and thickness, structure and morphology, pH alkalinity, water resistance and permeability, water absorption and water absorptiveness of sized paper, paperboard, corrugated fiberboard with COB test ISO 535, colorimetric parameters, opacity, color, yellowing glossiness, mechanical properties as tensile strength, and aging in a closed vessel at 100 degrees for only 5 days following the ISO 5630 protocol. Samples of the original packaging materials will be compared with the aged ones and examined about possible chemical changes by ADS analysis, which is employed for the study of the morphology of the surface of the packaging materials, as well as the elemental analysis of the samples. Experimental data are being collected and examined in order morphological, chemical, and mechanical properties of the green packaging materials to be evaluated and compared with the samples after aging process. Considering all the different approaches, the different kinds of materials needed in order to confirm the results and arrive to a more or less reliable evaluation of the new products, and considering also that other colleagues within this project collect their data as well, we understand that even it might not be an easy way to conclude, in all cases, it's a very important effort, a very challenging path to follow that, as every innovation, signals critical turn, we hope, towards a greener conservation approach of cultural heritage. Thank you for your attention. Here is our crowded team. Thank you again. Πώς φεύγω από εδώ τώρα? Okay. Okay. It's amazing. Ellen, oh.
So, proceeding to the next presentation, we are a little
last
behind
one,
not the last one. We have one more. We're a little behind the schedule. We have at the floor Elena Semenzin, which is an associate professor in environmental chemistry at Foscari University of Venice in the Department of Environmental Science and Informatics and Statistics. Elena holds a master's degree in environmental sciences and a PhD degree in environmental sciences as well, and has also completed a Marie Curie Fellowship at the Wageningen University in Netherlands. Her research interests are in the field of environmental risk assessment for both traditional and emerging pollutants, of course, by that describing nanomaterials along the life cycle of products, processes, and also safety and sustainability in the design. And she has experience in coordination of multidisciplinary research groups. And actually, at the moment, she's involved and responsible for GREENART Research Project, and this is also a member of SETAC and member of multiple advisory boards and technical committees and project excellence. So, Elena, thank you very much for joining, and the floor is yours.
Thank you very much for your kind introduction. Hello, everyone. So today I'm going to present you the approach that we are following in the GREENART project for evaluating the safety and sustainability of innovative solutions along the life cycle of products, materials, and chemicals. So as Professor Baglioni presented this morning, actually, I hope that you can see my slides. Can
Yes,
you
yes,
please?
yes,
Yes.
yes,
Okay.
we can, Elena.
Okay, thank you. So as Professor Baglioni explained this morning, in the GREENART project, we do have a work package focused on the evaluation of safety and sustainability along the life cycle of our solutions. So safety is related to assessing risks for both human health and environment. And then in sustainability, we are including not only environmental aspects, but also economic, technical, and social, ethical, and legal criteria. It was also mentioned that we're going to perform also life cycle assessment and life cycle costing of most promising solutions, and this will be coming at the end of the project. So, which kind of methods are we using in performing life cycle safety and sustainability assessment? We started from a framework that we developed and applied in the frame of another European project, which was called the Nano Restart. Here you can see the reference to the paper that was published. So we wanted to start from this framework, which is guiding product developers in evaluating safety and sustainability of their products step by step, early in a design phase. But then since in 2022, there was another framework published by the JRC of the European Commission, we decided also to use it. This framework is called Safe and Sustainable by Design, Chemicals and Materials. And by combining the two, actually, there are some common points and some differences. The most important thing in the framework of the JRC is that, as you heard this morning, it's very important to start from a series of strategies and principles that can be followed in the safe and sustainable by design of chemicals and materials. So here I mentioned green chemistry, green engineering, sustainable chemistry, safe by design. But then it's very important to assess once the product, the material or the chemical is developed, to assess its safety and sustainability according to different steps. And the steps that are proposed by the Joint Research Center are the 5 that you can see here. So the first step is on hazard assessment of chemical materials, so focusing on the toxicity and ecotoxicity of the material, but also on physical hazards. So not only hazards for human health and environment. And then step 2 and 3 complete the safety assessment, evaluating risk for human health and environment along the life cycle of the product. So in both occupational settings, but also user stages until the end of the life. Step 4 regards environmental sustainability assessment, and here life cycle assessment is performed. So the objective is to evaluate other kinds of environmental impacts, such as climate change impact or impacts on water use or use on other resources, or again eutrophication, acidification, this kind of impacts, which are not covered by risk assessment, of course. And then in step 5, we have to, according to this framework, to assess economic and social aspects. Here, life cycle costing can be used, for example, and social LCA according to data availability. So combining these two frameworks, here you can see the approach that we're following in GREENART. So we have stage 1, which is regarding focusing on hazard assessment, and is considering step 1 of the SSBD framework of the European Commission and the first 2 steps of the Nano Restart framework. And then in stage 2, we are performing right now screening sustainability assessment. This is covering the part of risk assessment in step 2 and 3 of the SSBD framework, but also a larger part, let's say a wider part on including also some social and economic criteria at the screening stage, together with technological criteria, so looking at functionality of our material. material of our solution. And then in stage 3, we will address mainly step 4 of the SSBD framework with life cycle assessment, but then we will include also some economic aspects with life cycle costing. This will be applied only to the most promising solutions, as they are tools, procedures that are very much data intensive. So stage 1, how we are performing hazard assessment. We are very much following, as I said, the framework of the European Commission, which aims to classify each material, in our case, both the ingredients of the different solutions and also the final product, according to a list of hazards, which, as I mentioned before, are human health hazards, hazards for the environment, and physical hazards. All these hazards are considered looking at the safety data sheets of the chemicals or the materials, and following also the approach proposed by the CLP regulation, the regulation on classification, labeling, and packaging. At the end, what are we able to obtain? A classification of our materials and chemicals according to the 4 levels that you can see here, where 0 level is the worst. You can see that is also reported that there is a cutoff criteria here. So what is proposed by the GRC framework is that the substances following in this class should not be used, should be prioritized for substitution or redesigned. The others, so level 1, 2, and 3, are much better, and therefore should be positively evaluated for the next steps of evaluation. So we perform this classification at ingredient level and also at product level, so mixture level. Here you can see an example. So we are providing this classification in terms of final level assigned, but also specific hazards that are assigned to that formulation, and the pictograms also that are proposed by the CLP regulation, European regulation. Then for the stage 2, this is the work that we are performing right now. We are performing screening sustainability assessment. Well, to perform screening sustainability assessment, we decided to proceed with a questionnaire. So it's a semi-quantitative method. And the idea is to cover all these aspects, so safety, functionality, and sustainability. Sustainability according to the 3 pillars, so environmental, economic, and social sustainability. And here in the figure, you can see that we have reported also the life cycle of our products. So the important thing is that we are performing this evaluation considering the whole life cycle of our products. So we first focus on the safety part here in the figure, because, as I said, in the first step, we addressed hazard classification. And so to complete and have the risk classification, in order to complete the safety assessment, we needed also to classify exposure potentials. So we decided to proceed also in this case with a semi-quantitative approach. So to evaluate exposure, we consider the 2 stages of the 2 steps of the SSBD approach. The second one, human health and safety in the production processes. So you can see at the raw material stage, at production and end of life. And the step 2 is covering the use stage, which is the one that is not covered by the step 2. And is focusing not only on human health risks, but also on environmental risks. So here you can see which kind of aspects should be considered. So for step 2, occupational health and safety during the production and processing of the chemical or material. So we need to consider the physical properties of the chemicals or materials, the hazards, of course, the amount of the chemical or material used, the frequency and duration of exposure, the operational conditions, and if there are any risk management measures in place. Of course, you must remember that we are in an early stage of development, so there is several level of details in which I can conduct this kind of risk assessment. At an early stage, most probably we will have qualitative information or semi-quantitative information to perform this step, and the same regards the step 3. So having this in mind, we developed a questionnaire to ask to the partners that this morning presented the different innovative solutions that are under development in GREENART. We asked them for general information on those, but then on production steps, if there were even any risk management measures in place in the production phase, which is the applicability domain of the solution, if there is any dilution applied, a description of the application phase, and if there are any risk management measures in place in the application phase. And then several other characteristics, physical-chemical characteristics that are useful to understand, which could be the transport and the fate of the materials in the environment, for example, if we have possible releases into the environment. So we are processing the results that the data that we obtained by our partners in order to assess exposure. And we continued in parallel also with the screen sustainability assessment, also regarding functionality and sustainability. So the safety aspects is covered by hazard and exposure assessment, which will be combined into risk assessment. And then for covering the part of functionality and sustainability, we proposed another questionnaire. This is a screening sustainability assessment, as I said, because later on we will have a more detailed sustainability assessment with LCA and life cycle costing. In this case, we decided to, as I mentioned, to have a semi-quantitative assessment according to a list of questions. I here decided to report only an example of the questions that we are using. Here you can see that different life cycle stages must be included. Here you can see the set of questions for the raw material stages. So there will be also questions for the other stages. And for each stage, we have different aspects which are considered: functionality, sustainability. And here you can see the 3 pillars: environmental, social, and economic sustainability. So we have questions for each of them. And then there is also safety reported, but actually here we will include the results based on the assessment that I showed you before. So what you should imagine that after filling in this questionnaire, we will collect all the information that are relevant for comparing different solutions. Actually, this tool is useful to assess the innovative solutions, but also to see whether these are worse or better or not compared to the benchmark, to what is already in the market. Here you can see just an example of the output that we can obtain. In green, you have the performance of the innovative solution. In blue, the one of the benchmark, according to all the questions that I showed you before that are related to specific criteria which are classified in a 0 to 5 scale, and are also highlighted in colors according to the specific life cycle stage we are assessing. So you can have an overview of your sustainability at a screening stage, considering functionality, sustainability, and also safety along the life cycle of the product. So what we are doing right now is to analyze the questionnaire of the Screening Sustainability Assessment Questionnaire. So the results that the different partners, the data that the different partners provided us in order to provide them with an assessment of the sustainability of their products. So they already have received in the first year the results on hazard assessment. And so this is a second step of assessment that is useful for all the partners to adjust their products according to this indication. And then after this, of course, the partners in GreenArt are going on in testing their products and identifying their most promising ones. And on those, we will perform life cycle assessment and life cycle costing. This way, we think we are really guiding step by step the development of these innovative solutions, following the SSBD framework, which is, recommended at European level, and really the European Commission is pushing for testing it to different fields. Indeed, we included GreenArt among the case studies for the testing phase of the SSBD framework, and now we are approaching the second feedback period, which is ending at the end of August, because the European Commission is asking us to provide feedbacks on how this framework applied into a specific field is working, if we have also suggestions for improvements. So this is the approach we are following to really guide step by step the development of safe and sustainable solutions in order to have at the end really something that is green, as in the title of our GreenArt project. That's it. Thank you for your attention. And this is the group that is involved in this work.
Thank you very much, Elena, for this presentation about the assessment for hazard and screen sustainability and life cycle, and how this can be included to the most promising solutions of green materials. Thank you very much again.
Thank you.
And now we go on to the final presentation of the day, titled Awareness Activities Insights from GreenArt. And our presenter will be Stefania Melandri from Warrant Hub SPA. Stefania Melandri was born in 1990 in Bologna. She has got a BA in Foreign Languages and Literatures and an MA in European Affairs from the University of Bologna. She's currently working as Operations Team Manager at the European Funding Development, BU of Warrant Hub SPA, and manages European projects funded in particular under the Horizon Europe Life EIC work programs. As former program development consultant, she worked at the United Nations Human Settlements Program Agency, New York headquarters, with a focus on the implementation of the SDG 11 Sustainable Cities and Communities through master planning, outreach, and organization of the events for multidisciplinary and intergovernmental stakeholders. Her work, association, and volunteer experiences have led her to travel frequently, for example, the Rio 2016 Olympic Games in Brazil, the EDUU project that saw Stefania as panelist at the first international conference on the enhancement of archaeological heritage in Iraq. So the floor is yours, Stefania.
I hope you can hear me.
Yes, loud and clear.
Okay, great. Because I have some problems with Teams. I try to share my presentation. If it doesn't work, maybe I can send you the link, but I'll try again. Hello?
Hello.
Can you hear me?
Yes.
Okay. So I have a problem.
Can you
I have
upload?
Yes, so I'm trying to share the screen, but it doesn't really work. Can I send you the link and can you share it for me?
Yes, of course, if you could send us the
Yes,
presentation, please.
I'm sending you the link. Just a second. Sorry, but I don't know why Teams doesn't allow me to share properly. Just a second.
No problem.
It's in our SharePoint, so I will send you the link to the presentation. Okay, I sent to Cristiana the link.
Okay, thank you.
Thank you. Oh, in the meantime, maybe I can try again sharing and see if it works. Is it working?
Yes.
Okay, so I left my camera off because I fear that it will go down. So hopefully it will be okay for the whole presentation. In any case, I sent the link to Cristiana. So good afternoon, everyone. I'm Stefania Melandri, so thank you very much for the introduction. And today I'm representing the activities that as GREENART we are doing concerning dissemination, exploitation, and communication activities. And I'm here on behalf of the work package leader, which is Antonio Mirabile. So I will give some insights and highlights on the activities that we are doing concerning awareness. So how GREENART is presenting itself to the external audience. I'd like to start with the objectives that we have, since we have three main different activities that are basically recognizable here. We are dealing with communication activities, dissemination activities, and exploitation activities. Even though they may seem similar, they are really different in the use of what we are going to communicate and the use that we do with the results of the project. Firstly, the communication activities are intended to reach the society, so the general public, to describe the project activities. In this case, we inform the audience on the activities of the project and the results. In this case, of course, we refer to different stakeholders, different kind of people that may be interested in the project activities. As for what concerns dissemination activities, here we have knowledge transfer, meaning that we communicate and disseminate the project results in a way that some others may use the results for their own activities as continuation also after the project activities. And this is reflected mainly in the scientific publications, where results are published by the project partners. In this case, of course, audience is targeted. It can be the scientific community, industrial partner, or policymakers. So based on the different results that we want to give and the different stakeholders that we want to engage for continuation activities, also after the project activities. We then have exploitation activities, and this deals with the use of the results mainly by project partners and organizations that are actively working on the project activities. In this case, of course, we set a plan of activities that we want to do also and mainly after the end of the project, since we will use and we will make concrete use of the research results that we will reach at the end of the project. Here you can see a timeline of the activities that we are doing. In particular, exploitation of results and dissemination of results have been starting right after the project activities has been kicked off. This because we need to have results to exploit and disseminate our project activities. Meanwhile, the communication activities of the project and the results starts in conjunction with the kickoff of the project. This because we will start, as I was saying, right away to communicate the project activities, since this is mainly addressed to an audience which is mainly general public and other kind of stakeholders that may be interested or involved in the project activities. In this way, of course, we will start with communicate mainly generic information concerning the project, and then we will disseminate and exploit in measures that the consortium will agree on. So, which are our objectives on these activities? As you can imagine, these are activities that are cross-cutting to the activities that the other project partners presented today. So they are cross-cutting towards all the work packages. Since these work packages, these activities address the communication to the general public. So we need to give the general public clear information and clear ideas on what the project is doing. And this, of course, is mainly also addressed to people that are not mainly involved in the project activities. They are not experts. In this way, we are developing a communication and dissemination plan to address awareness about the GREENART project and to increase the visibility of the project itself. So we develop an exploitation plan to ensure that the project expected impacts are assured also after the end of the project. We promote the knowledge towards scientific publication, as I explained, but also towards training activities that in the project are quite massive. So we are doing a very lot of training activities with interested stakeholders, interested students that participate. We also would like to share best practices as well as involving relevant stakeholders during the project to discuss what we are achieving, but also after the end of the project. This way, we will ensure that the results that we achieve will be also used afterwards. Lastly, of course, one of our ideas is to strengthen the participation of the stakeholders outside the consortium. As I was saying, the activities here are mainly referred to the knowledge sharing. So we need to communicate the project basically because the European Commission is asking it to us, but also because this is a research project. So we need to ensure that the funds that we are receiving are also communicated externally to the consortium. Also, this is done through networking activities that we are doing with other funded projects, but also with other initiatives, as Professor Baglioni presented this morning in the introduction. You can see here an overview and highlights of the dissemination, exploitation, and communication activities that we are doing. Mainly, we have set in the beginning of the project a dissemination and exploitation plan where partners agree on which is the pathway that we would like to follow to achieve our results. So we have been giving ourselves key performance indicators that we are revising during the project implementation. Actually, we are quite good on it because GREENART is well communicating itself, also disseminating. I will have some slides later to show you which are the results that we have achieved up to today. We have set, of course, policies and tools for dissemination and exploitation management, because as you can imagine, we need to be stick to specific guidelines and procedures that the consortium has given itself. And of course, this is also important to comply with EC rules, because we also have EC rules to follow, in particular for the publications that have to be open access, speaking about the project and showing the results that we have achieved, participation as speakers to international and national conferences, workshops, and other events to present the project, and all the partners are involved in these activities, as well as the exploitation and protection of results. Of course, as I said, this is a step that will come later in respect to communication and dissemination activities, because this is dealing with the use of the results that we will do. In order to communicate the project activities, we have set up a project website and a project logo, as well as a graphical identity. We opened social media, Twitter, LinkedIn. We are doing, as said, scientific publication, as well as participation to conferences. And in particular, we have a targeted newsletter, which is on a monthly basis, where we publish articles in relation to specific items and topics of green art. You can see here what is included in the dissemination plan. In particular here, as I was saying, and if you will remember, dissemination deals with the scientific spread of the project activities. So the presentation of results to targeted stakeholders and groups, in particular the scientific community. Here, of course, we reach our objectives by different kind of activities, starting from communication. And here you can see a lot of activities that we are doing. Dissemination activities, mainly dealing with conferences, clustering activities, scientific collaborations, and the scientific publication. As I said, we already have a lot. I will show you later where you can find them and where they are published. As for what concerns the exploitation plan, we are following a pathway that we have been presented during the first month of the projects. We started with the monitoring and mapping of the results that partners will have thought to achieve within the project activities. So we identified and monitored the exploitable results that we imagined in the beginning of the project. And this phase has just ended, since we organized the first seminar where we revised which are the key exploitable results that the consortium has given itself. And mainly the key exploitable results so far have been dealt with the information with the activities that you have heard in the previous presentations. So processes and products that the partners have been developing. Now we start the phase of positioning. So we are analyzing the innovations that the project is brought either to the market or in any case to the landscape where the project is in. And then we will start revising the exploitation plans. So we will elaborate with the project partners plans that will deal also after the end of the project. So in this case, of course, we need to imagine what we are going to do with the results that we are achieving. Of course, as I said, now we are in the middle of this timeline. We are studying the positioning of the innovations that we have been developing. Then we will arrive at the end where the exploitation plans will be elaborated with all the relevant project partners. As I was saying, the exploitation is mainly dealing with activities that partners are performing in the project. So activities in numbers, you can see that we are quite active. Also, Professor Baglioni this morning presented some highlights here. And you can see that we have been presented in several international conferences. We have been present in articles as newsletter in AMA. As I was saying, we have targeted newsletters that speak about specific topics and tasks of the project. We have done 28 training events. We have some highlights later in the slides. We have one project video that tells about the project, what we are doing, so which is the objective that we would like to reach and expected results we have. Scientific publications, again here we have been quite active in scientific publications and presentation in sectorial meetings. We have been participating to clustering activities, and this means of course at the Brussels level with other initiatives, either our projects or initiatives that deal with the same topic, and collaboration with other funded projects. These information are all quite relevant and important because, as I was saying, the GREENART has to be communicated to external stakeholders. Either this because we have strict rules given by the European Commission, and because it is important to give evidence of the activities that we have been doing. By doing this, of course, we have set some communication basics. Partners have available specific materials to be presented at targeted conferences, workshops, and so on. So the project presents itself via the graphics that has been given. So we have decided in the beginning of the project a graphic layout that lets the consortium and the project known at, of course, communication level, dissemination level, and via the social media. We have materials, as said, the brochure, the poster, and the roll-up. Probably you have already seen it to some events presented. It is important to note that these materials are available and are updated anytime that specific partners request it for specific conferences and events. And of course, this is important because they are basic information that presents the project. They are not that in-depth, but it gives highlights concerning the project activities. So this way, the partners have materials to present the project to the external audience, whether they would like to participate to workshops, conferences, and so on. As I said, we also developed a project video. I try to reproduce it. Hopefully it will work. Otherwise, I will leave you the link to see it.
I show it in the morning at the introduction.
Yeah, I know. Okay, so I can skip it. I know, perfect. So I can go on. Thank you, Professor.
Unless they want to see another time.
I can go on. Perfect. Thank you. So I go on then with the news and events. As I said, we are quite active concerning communication and dissemination activities. You can see here some extract of the project website where we publish all the activities that we have been doing. You can see here the latest that we had in 2024, and you can see that we have different kind of activities done. We start with specific workshops, but also have had conferences inside and outside Europe, but also specific targeted training activities. So training activities are quite important to share the knowledge that we have been developing in the project and to the knowledge transfer to students and other interested stakeholders. So you can see and you can follow all the activities that we have been doing and we will do in our project website. In particular, you can see also that we specifically publish activities related to newly joined partners to the consortium, but also specific requests, such as the one concerning the Porto Alegre that had quite severe flooding. So in this case, we try to communicate and engage on activities that may also give external views, external to Europe, as we have been requested to, but also inside. So in this case, we have been developing specific activities that have been targeted specific topics. We tried also to liaise with other partners, and in this case, as you can see and has been presented before, we have been doing specific activities concerning partners like Shiseido that will host one of our next meetings. It is important to note also that the Ministry of Culture in Italy have been organizing specific activities concerning the showcased activities, such as at Salone Internazionale del Restauro, which is quite a big activity in Italy, so a big conference. As for what concerns art that you can read, we have press conferences that have been published on our project website, the newsletters that I already showed you. So we have nearly one a month, and then the scientific publication. So once the scientific publication is peer-reviewed and accepted, it is directly published on our website. So you can read all the articles, scientific publications that have been published in our project website. So you can also follow this way the activities as well as the results that we have been reaching. I now pass to the second part of the presentation, let's say, to give you some highlights concerning the training activities that I've been doing, since, as I said, this has been a massive activity that has been organized. GREENART is a funded project, and as said, we have the important task to communicate what we have been doing. And of course, since we are dealing with the newly products, services, and processes, it is important to show them to students and stakeholders that may be interested in what we are developing. In this case, you will see some slides concerning activities that have been organized by the project partners. The latest one you will see. So we have a project training organized in Ljubljana, in Slovenia, where the latest advancement on cultural heritage restoration have been showed to the students. A workshop to the National Museum of Serbia, again May 2024, where we had theoretical insight as well as practical activities concerning project activities, as well as, of course, the cultural heritage restoration. So you can see that our events quite participated. This way, as said, we are able to share to vast audiences what we have been doing, not only by and via frontal lessons, presentations, but also through practical activities. And here you can see GREENART case study presented as preliminary consideration to the AAC 52nd annual meeting, and showed research and innovations in the restoration of paper and painted cultural heritage in Palermo, Sicily, again in May. So you can see that we have quite a lot of them. In this case, we had cutting-edge nanostructural fluids, green gels, and other sustainable materials presented and tested. Here you can see the one that I was mentioning before. So GREENART was showcased at Salone Internazionale del Restauro, a quite important conference and event here in Italy, organized and participated by the Ministry of Culture. Latest, we have a workshop at Tate Britain, again with the participation of the project coordinator and other specific partners. And again, here you can see workshops that have been organized in Lille in January 2024. So as you can see, we have been presented the specific topics one by one in the relevant events and trainings. This gives us the opportunity to present the project and make student tests what we have been developed. And as one of the last slides, I wanted to save the dates in your calendar in case you are interested, since we have two upcoming events which are quite relevant to the topics that we have been treated today and in general to the GREENART project. In particular, we have 10 and 11 April 2025, the second public training of GREENART, and then we have a public event in November 2024 in Ljubljana concerning green conservation practices in museums, libraries, and archives. So we have two upcoming events which are quite relevant to the topics, as well as, of course, to training activities that we are organizing. So I invite you to save the dates in case you are interested, since we would be more than happy to have you with us. And here you can see the contacts from Antonio Mirabile, that is the work package leader. As I said, I'm representing him today since he was not available to present the activities, and I'm involved in the work package as a leader of the exploitation part. So thank you very much. I'm sorry about the problems concerning the sharing, but in the end we were able to make it. Thank you very much.
Thank you very much, Stefania, for this presentation, for all these activities of dissemination you are working on within GREENART. We are a little bit delayed in time, so we don't have much time for questions. I will ask if somebody from the audience has to have a questions to put. And I would like, if it is possible, for the keynote speakers to open their camera and be with us in present.
Absolutely.
Okay, thank you. You are
For the group photo.
you still, yeah, for the group photo. Okay, you still are with us, and we thank you for your patience for this event. So I don't know if anybody has raised hand. I don't see. Christiana, I don't see. We have
No,
somebody.
we haven't received anything, so probably
Okay.
this is the time.
Probably the time for closing remarks. So I ask before I well, I put some my point of view of this session. I will ask Professor Baglioni if he has, as coordinator of the GREENART project, to add something, or any one of the other keynote speakers.
Well, I should thank you for organizing this meeting, and I hope it was useful, I mean, for Greek Conservator. So the project is open to any collaboration with people from Greece or other country. So if you have something or problems that you think might be solved or studied within the project, just let us know, and we will try to be of help in case we can be of help. So, but what I want to say is mostly is thank you very much for organizing this. That I guess was quite useful meeting, and we will see soon, I guess, in a while, in a few months, so we will see, but we won't see the Greek conservators. But you, I'm sure I'll see you soon. So, and for the test that you have to do in your lab, well, in case you have any problem, just let us know. I mean, any problem in the use of the, for example, just we sent to you, just we can have, I mean, Zoom or other meeting, and we can try to solve the problem in order to optimize the system we are producing and the time that you spend to testing them. Okay, thanks a lot, Athena, and Christiana, and all the other that participate, cooperate, I mean, and then spend times in this meeting. Okay, thanks.
I thank you, all the keynote speakers, for their very, very interesting presentations. And to conclude, if
there is a question.
There's a question.
I see there is a question. Yes.
Okay. Okay, you may proceed to your question.
Good afternoon, everyone. And thank you for this presentation, interesting presentation. The question for Professor Biro, are you prefer organogel or foam-based cleaning, or it depends on the grime or the deposits on oil painting?
So to whom is the question? Because I couldn't understand very well.
The organogels, well.
Can you repeat the question, please? Because I couldn't. So,
okay.
So to whom are you addressing this question?
For oil painting, which is better, organogel or hydrogel or foam-based cleaning?
Oh,
or it deposits on the grime.
So the first part of your question I could answer, or question I can answer now. Then the second one, no, because I couldn't understand what was the question. So the first, what is better, organogel or hydrogel? It depends on what you have to clean. If the artifact you have to clean is extremely sensitive to water, in this case you can use organogel. Otherwise, hydrogel are probably better suited for cleaning than organogel. So it depends on what you have to remove and the kind of artifacts you study.
Okay, what about foam?
What about?
Foam based cleaning.
Fungi. You mean fungi? The cleaning of
Foam.
fungi.
F-O-O-M.
Fungi.
Yes.
Fungi, you mean in, okay, so if it's fungi or fungi, you can use better if you use hydrogel, and then the cleaning should be performed not without microemulsion. Microemulsion sometimes can help, but with other solution. So in the gel, you can put enzymes, you can put simple chemicals, you can put salt, you can add anti-fungi agent. I mean, and also microemulsion and more complex fluid. So the gel, particularly the hydrogel, are say scaffold where you can, is a sort of spongi that you can put inside, where you can put inside what you need for cleaning. So that's they are very versatile. So for fungi, you can use hydrogel that are better than organogel, for sure. But then you need the anti-fungi, specific anti-fungi. It depends on the species, it depends on many things. So if you, I mean, this is a general answer. Then if you have a specific problem, you have to tell us, I have this problem that should be solved. So then we can precise.
Yes.
Otherwise, the answer can be only generic.
Yes, thank you so much.
Welcome.
Thank you.
Okay, I don't see other questions. Okay, so if you permit me to set some points for conclusions as described by the speeches in this conference, I think that the main points of the GREENART project as presented here today could be summarized in 4 points. Perhaps more than, in my opinion, these are the critical ones. That GREENART activities cover a very extended research to 4 different groups of materials: gels and fluids, covering materials, consolidants, and packaging materials. This is the whole, I think, the whole variety of materials that concerns the conservators, as well as GREENART proposes solutions for green sensors too, as well. The environment is it's a factor which is very, very important for museums and collections. The second, I think that it's each of these group of material presents a big variety of choices as well, which exploits a very variety of recyclable waste materials or materials produced by green technologies. This is very important because we can have solutions for the different kind of materials we are facing. The third is that it is GREENART is an open program. It's the research is realized in close collaboration with many kind of a big variety of persons from the field, conservators, and for enterprises, for universities, scientists from with different disciplines, and the application, the testing, the evaluation of these materials is done in the field, in the museums and in the big collections. And I think this is a strength. This is a strength of this program. And as the fourth is, as Antonio Mirabile has said in a previous meeting, that this is the first time that materials are designed especially for a conservation field. And I think this is a turn towards a more sustainable and a more function approach in the field of conservation. Well, of course, we could said much more about this very, very innovative program, and I think we will have other opportunities when the new product, the new materials will be finalized, and to discuss their functionality and their service in the field of conservation. I thank you very much, deeply thank you for joining us and be with us. And I thank you very much for this very kind and very generous and very fruitful collaboration we have. And we are looking forward to see you in the next meeting. Thank you very much.
Thank you very much.
Have a nice day.
Thank you
Thank
very
you
much.
very much.
Thank
You
you.
too. Ciao,
Thank you.
ciao.
Great to see
Bye,
you.
and have a nice summer.
Bye. Thank you.
Thank you. Bye-bye.
Bye.
Bye. Ama alkış günü.